Hash tables are data structures designed to efficiently store and retrieve information using keys. Their operation relies on transforming a key into a specific position within a table using a hash function, allowing direct access to the associated value without traversing the entire structure. These tables are notable for offering a constant average access time, making them especially useful when handling large volumes of data. Furthermore, each element is stored as a key-value pair, and the main operations include inserting, searching, and deleting information, thus facilitating fast and organized data management within the system. Consequently, one of the most important aspects of hash tables is collision handling, which occurs when different keys result in the same position in the table. To resolve this problem, techniques such as chaining and exploring alternative positions are employed, ensuring that all elements can be stored correctly. Additionally, strategies like rehashing are also used, which involves expanding the table when its capacity is exceeded, thereby improving performance. Furthermore, the efficiency of these structures depends heavily on the quality of the hash function, which must distribute the data evenly. Therefore, hash tables represent a fundamental solution for storing and quickly accessing information, and are widely used in applications requiring high-performance search operations.